Hi, welcome to this new video on my fischertechnik TXT robot and model Mirft2. Last time I managed to make quite some progress by doubling the speed of the motors, which had as a result that it actually could move. I swapped some parts so that the flexibility and stability are a lot better. There are still a few problems. One of those is that the legs are sticking through the wheels, which is limiting the amount of movement it can make. This is mostly impairing the real walking. I have to test it out yet, and for that I also have to test with real movement here what will happen. Will it walk? Will it just wiggle around one spot I placed on? Another problem is that so far I am using a net adapter, and of course that is nice for now, but if I really want to have it walk, it should have a battery pack. Something like this. Quite some weight, and the question is now, should I do it? Should I put a battery in place? I have no place reserved for it as yet. I could put it somewhere here. I have to make some reconstruction or put it between the motors and the controller, because right now I can lift the controller easy. Anyway, that would be a point. But let me just start by letting it run. And of course I'm still using my Android tablet. So I will just have it run and see what happens. Okay, it runs, and as you can see from the output, well, this is not correct anymore. Distance is, but the speed is 512 now, which is maximum. It grabs the frame, but there's still an SSH problem, so I can't copy them to the tablet. I have to use an SAP program, which is based on the tablet, but that's not an automatic thing. But for the rest it works now. So let me start by having it by changing the distance, because when it runs, oops, let me put the cam on or up, because when it runs now here, that is the distance, and I will try to get it further. See how that works out. Let's start with that. So looking at the code, I'll go to the first line that sets the distance, and I will do that stepwise. First to 55. See what difference that makes. And this is just plain old experimenting. And that's it. So let's save it and run it. See what happens. Alright, so this goes here, so I may safely put it to 60. Step by step. And then this as well. And let's see once again whatever happens. Okay, I think I'll skip to 70 this time, because those are really small steps. And the question is, how far can I go? And so far I can only do that empirical. So changed to 70. And the remarkable thing is, when you look at it, it looks like it is quite uneven once again. Right now this one is here, so let's see where it ends up when the full cycle is done. Okay, same place. I'm going to 80. And the question of course is, how far can I go? But I said that. And will it damage the motors? No, I don't think it will. Let's go again, see what happens. Okay, let me skip 20. Let me do that 20, because this is not even close to the maximum point. So that will be 100. and 100 to the other side. Let me show you. And yes, this is indeed the VI editor, which has a not fully implementation on the controller, because I'm doing this on via tablet, but I'm actually working straight on the controller with an SSH connection. So let's do it again, see what happens. Okay, again. That is getting somewhere. So I guess it will be, let's see, this is one more time. This is here. And now you can see that it is quite here instead of here. So those movements, it starts here, goes here, and then straight here. So this is more or less half a circle. And I have to keep that in mind when I will do maybe 110 now. It will go here and then complete here. So who knows where that leads to. We'll see. Now that the set distance is 100, I will first want to check how the behavior is when I keep it at 100. So what will happen? It ends here and goes here. Now once again 100 here and right here. This is not consistent. One more time. Will it go to here? No, it will go even further up. This is a very strange behavior. I noticed it before, but it gets clearer and clearer. And the problem is that, let me turn it around a little bit, or maybe the other way, that you can see it right here. It is very close to the frame, and it gets closer to the frame each time. So let me just see how much it takes to do that. And I think it has reached the frame by now. And the other thing is that if you look at this, it is not straightforward, it is sidewards. Also, looking here, it's also quite close to the frame by now. So let me put the focus on the back side, see what happens. I think I'll leave it at that. Okay, so much for speed change. Not speed change, but distance change. Next thing is that I, in this way, should think about reconstructing this part, because quite simply put, I want to move all around, because now it's just wiggling and I want it to move. So I'll have to find out a way that I can somehow move this axis there, put another wheel in here and put this through there. I'll have to extend this one too. So let's see how that will work out. Just to see how things may work out, I put another gear wheel next to it and shifted the axis a little bit to the right, to outside. This enables me as well to put this pin or axis or whatever through both of the gear wheels, and I had to replace this one by one of these. This distance is no longer necessary since the axis doesn't extend from the gear wheel anymore, so I can change this a little. But the advantage of this construction is that there is no limits in distance anymore, so I can keep going around, and the other way around, of course. So with this I can actually test if it holds. So I'll shift it and I'll have to re-establish the connection. And that is not going to work yet. Reconnecting with the controller, which is done. Another reconnecting with SSH. So and this is one and the same password for each controller so far. I'm back in, and now I'm going to edit this distance to, let's say, 150. Ouch, that is not wise, because the other motors, of course, are not yet done. So this is the idea. Anyway, let's see how this works out. It will jam probably, but just let's see. I'm very curious about this one. So, will it tear apart or won't it? Yeah, it will. Definitely. it won't run totally around. Right now this one is out of control. It completely went out. That's a risk. But anyway, those are the things to do. Another one, of course, is, let's get back to the code. I should, this is one side, this is the other, and the point is that with these things to do, because this is just the distance, I should do something else with the speeds, because the speed is going forward and going backward, clockwise and counterclockwise. So if I wanted to walk, I'll have to cancel one of these and then just let it go. But first I'll further try to reconstruct this so I can actually walk. With this reconstruction of double gear wheels done, not tested yet, there's already one difference visible, which is that it is rather flexible, which you can see here. It bends up, and here it bends up. So the question is, will this ever going to be working as intended? With my program being set to 150, the point is that I'm going to see if this works, and then go from there. So right now saving, and let's see what happens in reality. Okay. Well, okay, let me lift it, see what happens then. Why is this part not working? Okay, so there is something wrong with this. Let's check again. Here is a problem. I have to fix this gear. Okay. Another attempt. And that is much better. The question is though, how does it behave under when it's completely loaded, fully, and this is really going to be a problem. I'll have it stand on its feet. Let's see what happens. Okay, so once more, when fully lifted, so there are a few problems. So while it can run completely 360 degrees on its gears, this is a serious problem. And as yet I don't know how to fix it, because I have to really extend like this kind of pieces here to have it guided as solid as should be. So while this looks like a very good idea, its flexibility is way too much. And yes, that is a fix. It needs to be done. I don't know if I have enough parts, but let's check on this one anyway. Let's try that. With these parts added and these parts removed, it looks like it is less flexible than, say, this. However, this isn't an ideal setting. This is still very flexible, so rather doubtful that it, if put to work at all those four sides, that will actually give a good result. However, let's just see how this one thing works out. And yet again, one last time into the code. Here's the distance set, speed set, and the distance is of course going let's adjust the camera. The speed, the distance is of course how much it turns around, either clockwise or counterclockwise. The high speed is needed because of all the gears involved and its weight, which increased. Anyway, no more need for seeing the code right now. Let's just run it and see what happens. And yes, that is an oops. So, fully supporting it in the middle. Let's do it one more time. And then in the back side here there's one out of its place. Doing it again. Oops. And with the full view, one more time. So it can run full circle. Will it happen? I have no idea. This is obviously way too flexible. So I have to find a solution for that. Which one will it be? I have no clue. Remaining the battery will only add to the weight. So that means that I'll have to look into the flexibility of the frame as well. Will the full speed of the motors be enough to carry the weight of a battery pack? I have no clue. New experiments will have to show that. So with that, it's enough for this episode. Thank you for watching, and certainly to be continued with new experiments and etc. So, thanks for watching. Bye.